Greetings, Caymans. Welcome back. This is part 2 of a lesson about probability and one-way tables. That was the first part. And this is probability with two-way tables. You can see here on your screen, this is a two-way table. A two-way table has two different variables. One variable on this side. This is what year is it? So that's one variable. And then the variable shown in the top with these different towns, this variable is location, or where a student lives. So this is a two-way table. This is a principal at a certain high school was interested to compare how many students lived in nearby towns between two different school years. The table below summarizes the data. But just to check this out, we have a school year 2015 to 2016. We have a school year 2019 to 2020. We have how many students lived in Escondido or resided in Escondido in the 2015-16 school year. That's 411. There were a total of 1,245 students who attended this school in this particular school year. You also have, let's see, 1, 2, 3, 4, 5, 6. There are 7 towns represented, the most common 7 towns that students are from. But we also have students from other towns, so they would all be in this other town category. So for instance, if you lived in Fallbrook, Fallbrook didn't make the list, but Fallbrook students would be in the other category. The principal would like to select a random sample of students from these 2 school years and ask about their experience at the high school. Colleges, high schools do this. They like to see how their graduates turned out. The administrator has a list of all 2,487 student names with their contact info. Now these years are 4 years apart. So even if you were a freshman in 2015, that means you would have graduated before the following school year in 2019-2020. So there's no overlap. There's no students here that are like started in 2015-16 and then they continued to be students in 2019-2020. They would have been in high school for 5 years that way. And thankfully that didn't happen. So let's answer a couple of probability questions. Suppose one student is selected at random from the list. What is the probability the student selected is from Escondido? Well, you have this Escondido, and you would add these two, which I've done right here for you. That would be the probability of Escondido student would be 952 over the total from the list, and the total from the list is 2,487. On Schoology, we'd like you to leave the answer as a fraction whenever you get a one fraction kind of like this. Otherwise, we'll write the decimal. If you're writing the decimal, it would be 0.383. That's rounded to the nearest thousandth place. B, I have this circled, it's supposed to be a cloud, but it looks more just like a scribble circle. What is the probability the student is from Escondido, San Marcos, or Valley Center? If you'd like to answer that now, when you get to your try this, you could just type the answer in. But you can go ahead and try that. We did an OR probability in the previous video if you need help with that. Next one, suppose 2 students are selected at random from the list. What is the probability both students are from Oceanside with that replacement? So we have probability of Oceanside, we'll just say O, and we need 2 students like that. So to calculate that, we're going to have 2 sets of parentheses, one for the first student and then multiplying to the second student. Oceanside, we have 326 out of the total, 2,487. And since it's without replacement, I'm going to have 1 fewer on the list now, 2,486. And the numerator is also going to be 1 less because the first set of parentheses represents you have selected one of those Oceanside students, so now you have 1 fewer Oceanside student. We might ask you on Schoology to show your work, like type your answers. So we would ask you to type this fraction and then type this fraction and then type your answer as a decimal. 0.017, that's also known as 1.7%, but we would like it if you type your answer as a proportion, a number between 0 and 1 without a percentage sign. The next question is also about Oceanside again, shout out to Oceanside, but this one is with replacement, so you could try that on your try this. Next question, suppose three students are selected at random from the list. Question E is going to be for you. This is an example for you to try one without replacement. But let me remind you and walk through how to do one with replacement. So if the three students are from other towns, we want the probability of, I guess I'll have to do other like this since I already used O for Oceanside. Other. We're going to have three sets of parentheses since we have three students we're selecting. And the probability of other is 301 over the total of 2487. Now, if this is with replacement, once one student is selected from the list, maybe they're contacted, and then the principal doesn't scratch their name out. The principal still then selects a random sample, and it's possible that that same student is selected again. We still have 301 other students from other towns, and we still have the total list. So the with replacement is the basically in this context, the principal doesn't scratch off the name. So this could happen. This is kind of realistic if the principal makes a phone call, selects a random student, makes a phone call. Maybe the vice principal is also making phone calls. Vice principal selects a name from the list. They could end up picking the same student by accident. So they need to like cross off the name so it's without replacement. And then a third call is made, and the probability of getting a student from other is that same exact probability. We could write it as 301 divided by 2487 raised to the third. So the probability that you would get three students who are from other towns equals 0.002. When we get very small probabilities like this, we could ask you to write more decimals. So just to show you, we might ask you to write for a few more in case the first three digits are 0, 0, 0. But notice this probability, this is a very small probability. It would be really unlikely to get three random students from this list of almost 2,500 students where all three students are from other towns. We would expect at least like one Escondido in there. There's mostly like Escondido Oceanside students. So it would be really surprising if you had all three students from other towns. And then the next question, we're back to selecting one student. And I'd like to introduce you to an idea that's called a conditional probability. A conditional probability is a probability where we're not going to be dividing by our large denominator, the entire list number, 2,487 in this context, but we're dividing by something else. So let's see. Given a student from 2015 to 16 is selected, what is the probability the student is from Valley Center? The way that we would write this, given indicates to us it's a conditional probability. The notation we would use is we want the probability, we'll use VC, Valley Center, given that the student is from the 2016 school year, 2015-16 school year. The way that we calculate that, it's going to be a fraction still, it's a probability. Your denominator is going to be the given part. So we had given the student is from 2015-16. So a good way to do this, well, I wouldn't really recommend to do this on your paper, but a good way to do it is if you're asked about 2015-16 to cross out all the numbers that are not 2015-16 numbers. Okay, and now we basically have a one-way table, and we'd like to know, given they're from this group, well, there's this many students, 1245, what's the probability that they're from Valley Center? That would be 37. So the answer is 37 out of 1245. 37 out of 1245. So really key here with a conditional probability, our denominator is no longer the total from the whole two-way table. We'd like you to type the answer as a fraction whenever it's just one single fraction. You don't have to multiply or add anything to it. But if you wrote it as a proportion, we'd have 0.0297. That would round to the nearest thousandth to be 0.030. I have another one for you. This is given that they're from this school year. What's the probability they're from Valley Center? So the way that we would write that is the probability that they're from Valley Center given that they attended the school in this particular school year. So see if you could figure out what fraction that would be as you try this. And then the last question, conditional probabilities can be conditioned either way. On this first set on G and H, we conditioned on the year, but in I, we're conditioning on the location that the student lives. Given the student is from San Diego, that's our condition, given. What is the probability they attended during the 15-16 school year? Probability 2015-16, given, we use a vertical line for the given they're from San Diego, SD. So let's go back to the table. Given the student is from San Diego. So if we go back up here, given the student is from San Diego, I'm going to ignore everything that isn't San Diego. Might be a good lesson in life. Okay, that's everything that isn't San Diego. What's the probability that they attended the school in the 15-16 school year? So that would be 99 over a total of 210. So our answer here would be 99 over 210. You would type it as 99 over 210 into Schoology, but if you wrote it rounded to the nearest thousandth, it would be 0.471. If you wrote it as a percentage, it would be 47.1%. And then H is for you. As a try this, given the student is from San Diego, what's the probability they attended during the 2019-20? So you're looking for the probability they attended 2019-20 given that they're from San Diego. That equals what? And you'll answer that as a try this. Thanks so much for watching this video. I hope that was a good example of two-way tables for you, as well as a new idea about conditional probability. See you next time.